Hi and welcome. This time around we have an interesting project. I was approached by someone who was interested in having me convert this Harbor Freight half-ton Arbor Press into a Murinne Glass cutter. And if you're wondering what Murinne Glass is, Murinne Glass is made from canes like this. Glass rod like this is called a cane, much like a candy cane. And it's usually multiple layers of colors and shapes. And they want to trim them into sections, so they want to cut off multiple pieces along its length. And they want them to be somewhat equal in size. Sometimes they melt them together and make a flat piece out of them. Sometimes they're rolled around a glass jar. All manner of artistic pieces are made from this. So when I was approached, I thought, wow, what an interesting project. Let's see if we can pull this off. They provided me with the press and some cutter wheels that are for a hand nipper. There is a hand nipper that lets you cut glass, and you could cut Murinne glass that way, but it'd be kind of hard. You'd have a difficulty making it perpendicular, and probably some difficulty in making the pieces all the same size or relatively close to the same size. So we're going to try and modify this Arbor Press here to do just that. We're going to be making a bracket, cutting into this arbor itself and making a bracket that'll hold the wheels, and we'll be making a V block base for it that will mount to the base, and we'll take this wheel off of here, and we'll see what else we can do, see how smooth we can make this Arbor Press. It's not bad already, all things considered. And anyways, it should be a fun project, and I'm sure I'll learn a lot. So why don't we just get started? First step in this project will be to disassemble this 1-ton Arbor Press, and it's been disassembled before, so none of the screws or anything are tight. I left them loose on purpose. So I'll remove the collar first. That releases the gear and the handle, and the plate here comes off, and there is a kind of cheesy hardened steel plate under here. Looks like it's just maybe surface hardened. Can't really tell. That goes on there, and these two screws push on this plate that lies in this recess, sort of pushes on this guy to keep the gear engaged appropriately, and on the side it is centered just by these two bolts, and there's actually nothing. There is no plate that fits in here, which I find a little unfortunate, because I think it could benefit from that, make it slide more easily. So maybe we'll improve that. Don't know yet. Just right now, just trying to get the pieces off so that we can see what we have to work with. So this guy, I am going to cut in a little indented section on this guy, and that's where I'll be mounting the bracket that will hold the pair of wheels that will be used to cut off the glass. The base is just roll pinned in, not even a regular pin. That was probably an inexpensive choice for them. So it looks like this surface is relatively flat. But before I proceed, I'm going to need some datum surfaces to work off of, because this guy, as it goes down, the wheels are going to be about here, and they're going to need to be a very specific distance from this side so that I can design the V-block properly. In order to do that, I'm going to need some datum surfaces, so I'm going to probably take this over the mill and flatten off this side and the far side here so that I have two datum surfaces to work off of, and I will make them reference to this piece in here. So actually I might have to reassemble this guy and hold it in place rather tightly, so that I can get my measurements off of it, because how will I know what is flat? This is the only thing that's important. So I want to make this surface flat with the edge of this, and this surface flat with the edge of the front edge of this. So in order to do that, this guy will have to be in place rather carefully. So I might end up having to put together for that. I was looking at this. This was very roughly ground, and you know, I love the surface grinder, and I might just take it over and do some real light skimming passes just to clean this guy up and see if we can't improve the surface finish. It may make it work better, it may make it work worse. More contact points cause more friction, so maybe that's not a great idea. I don't know. This stuff looks like it's been hardened a little bit. We'll find that out. The gear teeth, boy, they've all been cut somewhat differently. If you look at it here, you can see that they're not all equal size, at least at the top of the gear. But what do you expect? Because this piece was just cast roughly and then chrome plated. So they weren't trying very hard. Obviously, for the price, they couldn't. Well, so let's head over to the surface grinder and just give this guy a little once over and see if we can improve the surface finish on this guy just a little bit. Yeah, as I suspected, it's not terribly flat. And it doesn't need to be. I'm just doing this because it's interesting practice and fun. I only went down 0.2 of a thousandth. Well, although it was wholly unnecessary, I don't know if you can see the finish difference, but I gave it a quick once over. I didn't take it all the way down because it was pretty unflat. I took maybe 1/1000 2/1000 off a side, trying to get it flat, and there's still left a little bit of material, but this should slide much more smoothly now. I noticed there's a little bit of waviness, and I think maybe that has to do with the fact that I've dressed the wheel several times and not rebalanced it, but we'll head back to fix that problem at some point before I use it next time. So next up, we're going to take this guy over to the mill, and we're going to get our datum points set here. We're going to mill this side and this side square to this guy. So we're going to have to remount this guy in there, and we'll be ready to go. I don't know if I need this part or not. I'm going to try and do without it, but for now, let's put it on to see. So that gives this guy something to sit into. Oh, interesting. So when it's in there, it can't actually go back against this wall at all because those gear teeth don't allow it to. That's interesting. Yeah, that's very interesting. So it's sort of held to this side and this side. So I'm going to pop this plate in here. Before I do that, let me back these guys out. I think we might be able to make a better piece than this. This is kind of cheese ball, isn't it? Everything about this screams improving the fit and finish, but that really isn't the point of this project. And it's not my Arbor Press, and all it's going to be used for is cutting glass, so we're not looking for extreme precision. So I'm probably going to have to snug these guys up. All right, so I put this guy back together again, and I've tightened these up now so that this doesn't even move. I was able to remove this without the Arbor gear mechanism without affecting the post, because I tightened all these down. I put a fair amount of pressure on the plate and a little bit of pressure on the side so I didn't score it, so that I held it in place. And now we can go over to the milling machine and mill these side datum points. Fixturing this guy in place took some real doing. I had some 8-inch parallels here, and because the casting only has feet on extreme ends with nothing in the middle, they were sort of ground, so I had to have the feet resting on something roughly parallel, and I clamped that at the bottom. I ran bolt holes through the base of it where it naturally mounts, and we got this guy within 1,000th or so across the range of this guy here. I just bumped it. So as I moved the x-axis, we got pretty darn close to no motion. So that's good this way. Now we need to go side to side. So I need to get a bar, set it on here, and then get the indicator on that next. And then I'll just tap this side to side until it's locked in. Alrighty, so now I've got it oriented correctly this way. I've got a parallel sitting on top of this bar, and we're within 0.5 over 6 inches, which is more than good enough, because this is not an ultra precision operation. And now I've just got to take really light cuts, because this is not the world's most stable setup. I mean, it's good enough, but it's certainly not enough for heavy cuts of any kind. So we're going to come back, we're going to set up for a cut, and we're just going to face this guy off here until we get a nice smooth finish, and then we'll figure out how to mount it on its side and do the same. Alright, so one side of the casting is much higher than the other, so it's going to take a few passes. Fortunately, this part is very thick, so we're just going to take it off until we just get a flat surface. That's all we want. And it doesn't have to be a perfect flat surface, just mostly flat. Alright, so we got our Z0, and we're going to take a bunch of really light cuts here. How about 10 thousandths? We'll see. I don't think it's going to touch on the other side. Holy cow, not even close. Well, this is cast iron. This is ugly stuff. Yeah, if you wonder about the height difference, there you go. That's the opposite side. That's quite a bit. Alright, so the high side is over here. I guess it isn't so much anymore. We'll try and only engage part of the cutter. Let's see if we can go a little bigger here. Let's try 15 thousandths. Okay, that worked. Yeah, there's a bit of vibration, so we definitely want to take it easy. So I've cleaned up one side, but the other side is, wow. I'm going to take a massive amount of material off to get there. I bet it's close to, well, let me set this as my new 0. Let's just see what it takes to touch. $46 thousandths. Well, I guess we could do a couple passes. Alright, I'll bring you back when I'm closer. At 50 thousandths, we just started to touch the other side. So now I'm going to walk it up 10 thousandths at a time here. to make the cuts kind of light. And we'll head over to 60 and do both until we're equal. Alrighty, one side down. I got to deburr it still pretty sharp. And one side down, and then we can do the adjacent side over here next. Gonna have to figure out how to fixture that one. This one was tough enough. Alright, so we're set up here to mill the side of this guy. And first thing I noticed was that the two bolt holes aren't aligned in a straight line. They're off by like a ½ an inch. It's like they drilled the holes randomly. The bottom is not square to the shaft. Not that that's a big deal for them, but I had to shim this 40 thousandths in order for it to be square. And as you can see, I've got it here pretty close. We're less than a ½ a thousandth that direction. Next I've got to get it this way, which I haven't done yet. And then we can machine this. However, once I'm all done with this, the bottom will not be square to anything because it never was. They machined it very crudely. I'm only hoping that this surface will be perpendicular to this surface, more or less. I mean, this isn't a precise part, but it's kind of annoying that it's so far off. I mean, shimming 40 thousandths over 4 inches is quite a bit. Anyways, so we're going to go side to side next. So I'm not going to cut the entire side. I'm just going to come to the edge of this rear machined portion, and I'm going to start the first pass at about 25 thousandths, I think, here. Okay. So I've got a few more passes here to clean up the whole side, and then I'll bring you back. And then what we're going to do is we're going to flip this guy over, and we're going to do the other side. It's going to require a whole nother setup. So let me just finish this and I'll bring you back. All right. Side one is done. So now we're just going to flip this thing over 180. Realign it all over again, which took forever to get this thing shimmed in. Anyways, that's where we're headed next, and we'll be back. Alright, so over here on the right side of the Arbor Press, I'm going to put 2 vertical holes for what I hope will be an adequate catch for the pieces of glass that are cut off. But if not, I'm also going to put 2 more side to side where she can mount a shield on here just in case. For the client. So we're going to start with the vertical holes, drill and tap, and then we're going to do horizontal holes, drill and tap. Alright, so we're going to do the other two screws. We're going to put one here and one over here in case we have to mount a shield that blocks this whole side. So that'll give alternate solutions in case my primary idea doesn't work, because setting this thing up in this position is pretty difficult. Okay, 4 holes complete on this side. Alrighty, next up we got to take the arbor and we got to remove 1-inch section here down 1/4 inch for the wheel press plate that's going to be mounted here, and drill and tap for 1/4 20, 2 holes, and we'll do that next. Alright, so we've got to go in a full inch, and we're going to do like 1/4 inch passes and maybe 100,000th depth of cut, and we're going to take it really slowly. And we're done. I think the surface finish could be improved a little bit. This is not the sharpest end mill because I've used it to cut hardened steel a bunch of times. That's what it's designed for, and I thought this might be slightly hard, although not terribly. Anyways, next up, drill and tap, and then we can hop over and work on the next piece. Alright, so next up, we're going to drill and tap 2 1024 holes. And if people wondering about the pressure being applied to the screws themselves, you don't have to worry, because what I'm going to do is I'm going to make the plate that holds the wheels just a little bit, the holes just a little bit loose, so that it can push up against this boss here. And I am going to grind this flat so that it mates up perfectly. That way the screws will just be keeping it in place, and all the force will be up against the boss. And we're going all the way through just to make it easier to deal with. Alright, so this part's done. Now we just need to make the piece that goes in it and the V-block. Thanks for watching. Hope to see you in part 2.